Okay, this is TouchyFeely number 1, and this is about how good a current source is. And again, I'm having trouble grabbing that corner. There we go. Okay, and how good a current source is, and there's two things that make a current source good. There's having the same current on the left and right, and the other thing that makes a good current source is that when you move the voltage on the output right here where it says I out, if that changes the current a lot. And this again is talking about that second one. So if I move the voltage here, how much does the current change? And this the thing that happens here is that when you change the voltage here, the current through this transistor increases. Let's say you raise the voltage at the output here, raise that due to channel length modulation, the current increases. And this transistor right here, because the drain is connected to the gate, it has to move very little to accommodate the new current. And because it has to move basically zero, this current increase, and nothing turns down the VBE or VGS on the second transistor. So that's a bad explanation, but let's go over here and see the difference. On this one, when you raise V out, you've just increased the VDS on this transistor, which increases the current. And this thing says, okay, I have to accommodate this new current, but its gate voltage is fixed, so it has to accommodate the new current by changing VDS. And when it changes VDS, it has to change more than the node on the Wilsons. So this node on the Wilsons right here, that changes hardly at all. But here, any change in current makes the drain voltage change a lot, and that turns the VGS back down on this second transistor. Okay, so let's do that. So let's do V out, and we're working on the cascoded first. Let's look at the cascoded first. So if you raise V out, then current goes up, and the reason is channel length modulation. Stretch a little bit more if I can grab it. Yeah, okay, right. And then because the current goes up, and we're talking about the current in the right side, because that current goes up through the top transistor, I should say top right top transistor, that means current goes up through, current through bottom transistor also has to go up, since any current going through the top transistor also has to go through the bottom transistor. Okay, and the bottom transistor, so a bottom transistor, to turn up the current, VDS goes up to accommodate the new current. Should say current through bottom goes up, which means VDS goes up because VGS is fixed. And because VDS of bottom goes up, source of top goes up, and because source of top transistor on the right goes up, current through top goes back down. So you started out by increasing the voltage on the output here, and that turned up the current in this top transistor, which turned up the current in this bottom transistor, and this transistor had to increase its current by changing VDS, but when it changes its VDS, it turns down the current back in this top. Okay, in the improved Wilsons, you bring this voltage up, the current increases, but because any change in the drain right here also changes the gate, this moves very little, and so it doesn't turn the current back down on the Wilsons.